Moving on to another example, so when ax cubed plus 2x squared plus bx plus 7 is divided by x plus 2, the remainder is 3. When it's divided by x minus 3, the remainder is negative 2. Find a and b. So the first thing I'm going to do is I'm going to take our dividend and label it as f of x. So I just rewrote the dividend over here. Now, how many unknowns do we have in the dividend? Well, we have to find the a and b value. So we got 2 unknowns. And whenever we have 2 unknowns, how many equations do we need to find them? Well, we're going to need 2 equations. So let's find our first equation. So equation 1. So we're told that when we divide this dividend by x plus 2, the remainder is 3. So we can make an equation with that using the remainder theorem, right? So if our divisor is x plus 2, to put it in the x minus k form, we would put x minus negative 2. So our k value is negative 2. And if you remember, the remainder theorem states that when you're dividing by a x minus k divisor, the remainder is just f of k. So in our case, f of negative 2 is equal to our remainder of 3. So taking the dividend and plugging in negative 2 for the x values, our a and b values still stay there. So negative 2 to the power 3 is negative 8, so we'd have negative 8a. Negative 2 squared is 4, times 2 is 8, minus 2b plus 7 equals 3. Now bringing this 8 and 7 over, we'd have negative 8a minus 2b is equal to 3 minus 7 minus 8, which would give us negative 12. And we can simplify this equation more by just dividing everything by 2. 2 is a factor of all these expressions. So we'd end up with negative 4a minus b is equal to negative 6. So this here represents our first equation. Now let's find our second equation, and we can use that with this piece of information over here. When the dividend is divided by x minus 3, the remainder is negative 2. So again, using the remainder theorem, since our divisor is x minus 3, that means f of 3 would give us the remainder if we just plugged in 3 for the x values in the dividend. And we're told that the remainder has to equal negative 2. So plugging in 3 for the dividend, for the x values of the dividend, we end up with this. The a and b's, we still don't know what they are, and that's equal to negative 2. So simplifying all this, so 3 to the power 3 is 27a, plus 3 squared times 2 is 18, plus 3b, plus 7 equals negative 2. Now taking the 18 and the 7, bringing it over, so we'd end up with negative 2 minus 7 minus 18, which would give us a value of negative 27. And we can simplify all of this by dividing it by 3. 3 is a common factor in all of them, or the greatest common factor of all the expressions. So 27 divided by 3 is 9, plus b equals negative 9. So this here represents our second equation. So now we got 2 equations, 2 unknowns, and we can use either substitution or elimination to solve for a and b. So what I'm going to do is I'm going to take equation 1 and I'm going to isolate for b. So I brought this negative b over and I brought the negative 6 over. So we end up with negative 4a plus 6 equals b. And then I'm going to take this b and plug it into equation 2. So doing that all up here, let's rewrite equation 2. So we got 9a plus, I'm going to sub in for b this negative 4a plus 6. So 9a plus this b value is equal to negative 9. So then simplifying this, we get 9a minus 4a plus 6 equals negative 9. So 9a minus 4a, that gives us 5a. Bring the 6 over. Negative 9 minus 6 is negative 15. So divide both sides by 5. So a is equal to negative 3. And then I'm going to take this a value and plug it in here to solve for the b value, because we know b is equal to negative 4a plus 6. We got that from equation 1 when we isolated for b. So taking this negative 3, plugging it in for a, plus 6, so we would have 12 plus 6, so our b value is 18. And those are our final answers. A is equal to negative 3 and b is equal to 18. Now, you can also check your work by taking these a and b values, plugging it into the dividend, and then using the remainder theorem, or even just doing long division or synthetic division if you have the time or you want the extra practice. So take that dividend with the a and b values, divide it by x plus 2, see if you get a remainder of 3. And then divide it by x minus 3, see if you get a remainder of negative 2. And if you do, then you know that, that your solution is correct. If you're not going to do synthetic division and long division to check, I would at least do the remainder theorem to check, and then just see if these equations hold here. This f of negative 2 equals 3, and this f of 3 equals negative 2. So you plug in negative 2 for the x values, see if you get 3, and plug in 3 for the x values, see if you get negative 2. Alright, so let's do a quick recap of what happened here. So we were given a dividend with two unknowns, and we had to find the two unknowns a and b. So since we have two unknowns, we need two equations. So the first equation we got with the piece of information saying that if we divide it by x plus 2, the remainder is 3, and we can use the remainder theorem to make an equation for that. So when we're dividing by an x plus 2 divisor, the remainder is equal to f of negative 2 if f of x is equal to the dividend. And since we know it's equal to 3, we made that equation, and then we got our first equation in terms of a and b, so negative 4a minus b equals negative 6. Then we found our second equation with the piece of information saying when the dividend is divided by x minus 3, the remainder is negative 2. So we can make another equation here, f of 3 is equal to negative 2. And then doing all the algebra, we got our second equation of 9a plus b equals negative 9. So then what I did was I isolated for b in equation 1, and then subbed in that b into equation 2, just up here. And then we were able to solve for a, got negative 3 for a, and then plug this a value back into equation 1 to get a b value of 18. Again, you can check your work, take those a and b values, plug them into the dividend, and see if these two equations hold. And if they do, you know that you got the right answer.